And with that said, I'd like to introduce you to Swapnil Mehta. He'll be speaking for us today.
Thank you for that introduction, and thank you all for being here early in the morning. I appreciate it. My name is Swapnil. I'm an incoming postdoc at Boston University and MIT. I just wrapped up my PhD as of yesterday at New York University. Thank you. Today I'm going to talk to you about something slightly different from what you might have heard around here. I'm going to talk to you about some work that some students did. And these students built out a very interesting piece of software that scaled up to hundreds of gigabytes of Twitter data. We analyzed a bunch of activity ranging over the last 2 years, specifically activity that targeted certain media narratives that were spread by state-backed media in Russia that some people claim are pillars of disinformation. When I say some people, I mean mainly the West, US. What I want to talk about today is mainly about how we can do better quantitatively identifying these kinds of activities as opposed to relying on arbiters of truth, authoritative sources, or I should say authoritative sources, those kinds of things. So with that said, let me get into my slides. I think this was a very fun story I read about, well, I should say fun, interesting, scary, but from the perspective of how information affects people. The intel on this wasn't 100%. This was what a guy called Edgar Madison said. Now, Edgar Madison was one of the people who was susceptible to the Pizzagate controversy. For those of you who are unfamiliar with Pizzagate, it was this very famous sort of conspiracy theory that propagated, and I say famous because people really believed in it. There were protests, physical events held, hundreds of people gathered, believing in this idea that there were child trafficking rings or human trafficking rings run out of the basement of a pizza parlor in DC, among other things. And this guy believed in it to the extent of driving 400 miles, going up to the pizza parlor, shooting up a locked door. Luckily, no one actually got injured in that. It could have gone horribly wrong. So it's just a very striking example of how misinformation actually affects people. And they made a movie about it, no doubt. They made a Netflix show about it, if I remember correctly. The point is, lots of us have been fooled by misinformation. Lots of us are likely to be fooled by misinformation going ahead. And this is pre-generative AI. This is before everything on the internet was generated by AI. So it's going to get much, much worse. And there are real financial costs, right? When I heard someone in a talk say it's hard to convince management, well, when you throw these numbers at management, they're more likely to be convinced than when you tell them, hey, people are fooled by misinformation. So Gen AI, and there is work from not only people outside of OpenAI, but work by people within OpenAI who have sort of confirmed that, hey, Gen AI generates misinformation. They nicely marketed it as hallucinations, but at the end of the day, it is a fact that was manufactured that isn't actually true. And people believe that because, hey, the everyday user doesn't necessarily know that AI has failure modes. They don't necessarily know that this might not be true. And they definitely don't know enough to go and verify every single claim that is spit at them by an AI model through a company who offers that model by using an API that someone else offers. So with that said, I think platforms understand this. I don't think, especially social media companies, they're very well aware that they have a problem on their hands and they need to address this. But by and large, the idea of content moderation being based primarily on content is kind of a design flaw because content is subject to change very quickly, especially with generative AI content. You can generate any kind of content at the click of a button. And this is not just text, this is videos, this is audio, this is images. We've seen all the deepfakes come out. You've heard all the talks about how social engineering worked out because people spoofed voices, because people spoofed videos, so on and so forth. So platforms are treating this, and they're trying very hard to do this. But by and large, they treat the symptoms, not the disease necessarily. What I mean is all of the policy updates that come out happen a lot of the time after the harms actually come out. And these harms disproportionately affect those who actually don't understand the technology very well and are most susceptible to being affected by the harms from this technology. So what I want to say is we need slightly more focus on beyond content moderation to actually moderate content. What do I mean by that? Well, we need to start looking into behavioral models, and to be fair, lots of companies have. I worked at a couple of companies, and all of them have some sort of reputation-based mechanisms for actor identification. They have different kinds of scoring, internal credibility metrics. We also need to focus on multilingual signals. Again, companies are doing this, but this is slightly low effort task, mainly because there are certain languages that a majority of your population is going to fall into. They're going to be the people giving you revenue or driving your business. You want to obviously focus on them. But the challenge is there are so many other languages out there. You're not going to be able to develop an expertise for every single language out there. We don't have necessarily multilingual classifiers in industry that work equally well for all languages. And so you're naturally going to suffer from some modes being missed by your company. In this case, you also need to understand cross-channel narratives. And this is where industry famously has very siloed off development. Facebook doesn't study Twitter. Twitter doesn't study Instagram. Instagram doesn't study TikTok. In fact, organizationally, you can't. You can't really get another organization's data and study what is going on that platform. But the bad actors, they have access to every platform. They have access to deploy the same techniques, test out what can bypass filters on one platform from another platform, and they go out and use that against platforms. Lastly, when you actually have interventions, you want to be able to effectively deploy those interventions. And what I mean by that is lots of interventions are deployed out there. For example, some of the research I conducted was into understanding how interventions or these misleading warning labels that Twitter stamped on top of a lot of former presidents' tweets resulted in an increase in engagement with those tweets, as opposed to what I would hope they expected was to reduce the engagement. So these kinds of backfire effects, I'm not saying that's the entire effect, but I'm saying that was one part of the effect that we estimated, and that was a causal effect. So we estimated that pretty robustly. And I'm not saying that that's the only outcome. I'm saying there are effective interventions out there as well. But again, there is very little data sharing about what worked versus what didn't. And this siloed off nature of social platforms results in bad actors having slightly an upper hand. So what can we do? Well, today I'm going to talk about this case study where we were able to externally identify certain metrics that we are able to use to quantify coordinated behavior on Twitter. And this was a project for the Sunday Times. So let's get into it. Well, so the US government says there are 5 or more maybe pillars of disinformation that Russia uses in order to promote propaganda, according to some reports they published. These are official government communications, state-funded global messaging, proxy sources, social media, and cyber-enabled disinformation. I'm going to talk about the 3 I highlighted in orange there in bold. So state-funded global messaging, social media, and cyber-enabled disinformation. I'm going to give you a very clear-cut example of how we went about and studied this. So there are 2 media providers, Russia Today and Sputnik News, that have been banned by different platforms. The EU says, hey, they're bad, for lack of a better word. In general, spreaders of disinformation. And what I want to do is take a second and step back from that. Let's say they're just media providers. How would you study a particular media provider? Well, you would try to quantify their effect on social media. When we go out and do that, what we find is 8,000 different articles that they published over the last 10 years. We take a sample of those articles, specifically the last 2 years, because activities change very frequently. We want to see what is most recent. And the question we ask is, what is unusual about their spread online? So this is the kind of data we have. We have the article titles, we have the article URLs, we have a bunch of content from the article, and then we have the source for this article. What you see on the right on the screen there, or maybe my right, your left, either way, what you see in the network plot on the screen there is the interactions that we create, the interaction networks in particular that we create around each media article that has been posted to social media, specifically Twitter in this case. Well, what does this mean? So in the center, the black dot in that diagram, you see the news article of interest. In red, we track every user that engaged with this article of interest, specifically sharing. And then for each of these users, we have an interaction history. So every user is a certain data point, but there's so much more to a user than just engagement with that one article. So we want to go ahead and identify what else they care about, what else they have been doing on the platform. And the sort of pseudocode or the algorithm that we walk through is we collect all of these interactions, we compare their behavioral dynamics and sharing patterns, we score their account history through graph and machine learning estimators, and then we scale this to millions of accounts and interactions, because without scale, really, this kind of research is useless. So what we find from this is that influential accounts that were created years ago are still active on Twitter. This was as of last year. I don't expect any significant change given that Twitter downsized to that extent. And I was an intern at Twitter, so I saw things from both sides. Influential accounts are still active. This was work done outside of Twitter, just to be clear. So influential accounts are still active, and they have lots of followers. So the median, there are very few accounts with a humongous amount of followers, so on the order of millions. But there are a bulk of accounts that range in the thousands to tens of thousands of followers. And this is really interesting because from a bad actor's perspective, one account with 1 million followers is really bad, but 10 accounts with 10,000 followers are really good. Because if you look at the Twitter algorithm, the way that the algorithm promotes content is it looks at bursts of activity. Even if accounts engage in a burst of activity, independent of how many followers these accounts have, that burst of activity could contribute to it trending. There's obviously other factors, and the algorithm is now public, so you can actually look it up. But this burst idea has been validated as one of the features that contributes to virality. So from that standpoint, the bad actors are doing really well in terms of having access to these kinds of accounts. And again, I want to bracket that by saying I'm not going to say bad actors yet. I just want to say actors that engage in the promotion of information, potentially unreliable, from these two media providers. So I'm not the authority that tells you who is bad, who is good. I'm the guy that gives you the data analysis, gives you the scores, and lets you make that decision for yourself. Content-wise, can anyone tell me which, let's abuse terminology and say good actors and bad actors. Can anyone tell me what is the difference between these two kinds of content? Which could be good content, which could be bad content? It's really hard to tell. A lot of it is the same keywords, a lot of it is the same kind of language used, just used a little differently. Which again kind of underscores the fact that keyword-based methods are unlikely to work very well when actors are reasonably smart and can actually play around with narratives. And this is, again, I want to underscore this pre-generative AI. You can imagine now this is much worse, and there's clear overlap over the language used by all kinds of actors. So the first thing we did was through machine learning at it. Why not? I should caveat this by saying I'm a machine learning researcher and I don't trust machine learning all the time. In fact, most of the time I don't trust it. I try to find other ways to do interpretable analysis in addition to machine learning. I'm just starting with this because people find it cool. So we used large language models to identify propagandist parts of speech in this content. In particular, we had, you can see probably the graph is too small there, but there are different kinds of classes in this kind of propaganda speech, and 2 of them or 3 of them are labeled in the content itself. So calling some people R nationalists qualifies as flag waving, calling someone pranksters or neo-Nazis, those qualify as name calling, and there are other brackets of like causal oversimplification, different types of propaganda speech. This was built off of a Roberta-based classifier that was fine-tuned to identify propaganda speech in news headlines. So we were very careful about using classifiers that were trained on the same domain of data, which I don't know if a lot of people do out there. You find a model, use it, get some results. As long as the results look good, you kind of go about it without worrying about dataset drift, out of distribution data, so on and so forth. All of this led us to find some interesting groups. So I guess you were saying I should walk away from this because I have a lip. Right. So we found some interesting subgroups based on behavior. And specifically in this case, what we were trying to find was which are the most active accounts, what are the most interesting accounts from our standpoint, because there's a lot of noise. If you look at these articles and you go to Twitter, you'll find 200,000 different matches on who shared it, who engaged with it, what did they do. And you're not interested in all of these 200,000 accounts. You're interested in a specific subgroup of accounts, and I'm going to tell you why you're interested in that subgroup of accounts. So we have different let's summarize the slide to say we have different metrics to identify these subgroups of accounts. The general overview of the kinds of activity we found was looking like this. And this is a heat map where I'm looking at user groups on the x-axis and articles arranged in a chronological sequence on the y-axis. So this heat map, in a sense, every box represents the frequency of sharing by that of those articles by that group of account. And you see the left half is dark violet, indicating a much lower sharing. The right half is more yellowish, indicating a much higher level of sharing. The interesting thing is that's before and after the war started. So the right side is when the war effort started. Russia invaded Ukraine. There was a lot more activity going around media narratives around the articles that these two outlets were promoting in particular. And these accounts are engaging in that promotion of articles. So kind of like a natural activity. Well, we found specific subgroups of accounts that retweeted the same kinds of articles incredibly frequently. And again, the question is, yes, so you have some active subgroups of accounts. Why do you care about that? Like, people can be interested in things. Well, the interesting thing is, if you can see the small plot where I've redacted the account names because Twitter doesn't allow us to share those. The thing is, these actors shared the same narratives 40 to 50 different times with about 3 seconds of a difference between them. And 3 seconds was average. Sometimes it was much less. It just seems like if you and I share something 40 different times within 3 seconds of each other, that's not really organic activity. We can be interested in the same content. Sure, we can share it within a couple of minutes maybe of publication. Maybe once or twice we share it very quickly. Maybe someone tells us to share it. But 40 different times is not really organic. And that's like a very clear quantitative signal. That is not machine learning. That is just smart, scalable graph algorithms that tell you a very simple fact, boiled down from these billions of data points, millions of accounts, hundreds of thousands of articles, to this one-line insight about these accounts. And we did this. We scaled this up to identify all of the accounts who were sharing these articles in a coordinated manner. So we have a website up, actually. You can take a look at it whenever you like. This is a project we did for the Sunday Times, mainly because investigative journalists wanted to understand how media spreads online. And this is kind of replicable to any media provider. This is just, we plugged in some URLs and some articles from one or two providers because we wanted to understand what it takes to step beyond authorities telling you something is disinformation or misinformation, and trying to understand how you can identify coordinated and authentic behavior around a set of media providers. And then the interesting stuff, I mean, my background is in computer engineering, so I like scaling things. I used to work on machine learning models, and scaling things to production is really fun. So we built all of this on Google Cloud. And I started this by saying this was undergraduate students. Well, we've been training students for like 6 years now. So now they're growing into machine learning engineers, data scientists in industry, and they're all interested in contributing to trust and safety tooling. And this was like a part-time effort that we did. But once we did this, we were like, hey, this concept of interaction networks that we came up with, it's really general. Like, every social media platform is, in a sense, a large graph. The affordances of those graphs vary. The nature of interactions and thereby edges vary. But it's a large graph. So the question is, where else can we use interaction networks? And specifically, this graph structure of social networks turned out to be to our advantage. Because then with this, we could also analyze how these accounts shared YouTube links. So like I said, this interaction network, that included all of the past interactions of these accounts. And a lot of those past interactions were links to other platforms. So these accounts were likely used in campaigns to promote other videos, other platforms, Telegram links. We're still looking into those. But what we are able to do is, and this is a high-level aggregate of YouTube data, because again, we can't share specific data unless there are certain requirements are met. But on aggregate, you can see that there's a lot of views, a lot of channels, a huge amount of content that they shared on Twitter relating to YouTube. And when we dove into this, we realized we had a major challenge on our hands, because this requires multimodal analysis. So we need to now build video analysis models. We were able to build those out. We're now parsing through hundreds of thousands of videos to identify what exactly is the narrative. What are the topics? And most importantly, what are the comments under these videos? because the comments are also one of the ways that you engage people who don't actually watch the video, but they see the top comment. Maybe there's a link there, they click on it. So for comments, we ran into this challenge of there not being enough language translation pipelines out there that served our use case at cost. So again, we didn't have the money to pay for hundreds of thousands of comments to be translated without any confidence scores in this is definitely the language that this comment is in. So we built out our own. We used, there's a large open source community around large language models. We have experience in natural language processing, picked up an open source model, scaled it, deployed it internally, and now we have an in-house language translation pipeline that we can use across different social platforms. And with that, we get to a part where we were like, okay, this is all like mainstream social media. I told you about YouTube, I told you about Twitter, I can do the same thing for a bunch of different platforms. Well, we're now looking into encrypted platforms and credential leaks because these same kinds of coordinated networks also have data breaches on different encrypted platforms, different encrypted sources. And particularly, I'm interested in Telegram and WhatsApp because a lot of users in what we call global south countries, they might not even know what the internet is in a large case. Taking the example of my own grandparents, they don't know what the internet is, but they know what WhatsApp is. They know messages get sent to them. They know, excuse me, they know they send those messages to other people. So for them, when they get scammed or when they get defrauded, it's because someone from Dubai called them up and they didn't know better than to not answer. Or someone texted them and they didn't know better not to answer. So what we're interested in now is like this platform data donations research model where we reach out to these users, ask them to install some plugins, extensions, tools on their mobile phones. We can decrypt certain encrypted, end-to-end encrypted platforms in a way that doesn't violate platform policies. I don't know if decryption is the right word to use there, but we collect data that the users donate to us. Use that to identify certain coordinated networks, campaigns that they run, and I'm waiting to hear back on grant proposal being funded so we can deploy this at scale. But I hinted at this, specifically when it comes to building tools for the global south. It's really hard to think about deployment because you can't just think of, I'll create a website and people will come here and visit it. In fact, for fact checking, that almost never works because the people you want to fact check are never going to really come to your website and read the fact check. So how do you operationalize these kinds of tools and technologies in a way that the end user doesn't have any friction in terms of using it? Or basically, like, how do you make it easy for people to benefit from the tools you build? Specifically thinking of the global south in our case. So what we did was LLMs came out. We were like, we have a lot of fact-checking organizations that want to deploy their fact checks at scale to the end user directly. We built out two systems for them. So on the left, you see the first one. This one talks about check your claims and information for real or fake. So this is, we used a COVID fact-checked claims data set. What we did there was we made a chatbot answer questions over this data set. The simple benefit of doing this was it operates over a fixed set of data. It does not use its pre-trained knowledge to answer questions, but rather relies on the specific data that is provided to it. It can still benefit from the semantic understanding of text in general, learned from its pre-trained data set, but it won't use that to hallucinate facts and share misinformation with the end user. So in cases where you're really like tight on having to be close to the facts, this becomes really useful. And the second thing we did was, again, LLMs are useful. You're going to build a website and a chatbot, that's great. We were talking about users who don't really have web browser understanding, who are not really going to go to a URL unless you send it to them in an instant messaging app. So what we did was we ended up deploying this on, WhatsApp is not here, but we deployed it on WhatsApp. Telegram was much easier to deploy on because we didn't need any platform permissions to do that. So we built out a Telegram bot that talks to these end users. COVID was one of the use cases. The other use case we picked was talking about menstrual health. So in Bangladesh with a nonprofit, we collected a bunch of menstrual health information, menstrual health and hygiene, because, and I don't know how many of you know this, but about 50%, I was reading some research yesterday or last week, that said about 50% of girls, when they actually reach menarche, they don't have an idea about what menstruation is. And menstrual hygiene, period stigma, results in a lack of discussion of appropriate menstrual hygiene. And that's really dangerous because that can have serious health consequences. So identifying that as an issue that this kind of technology can really benefit we reached out to an NGO, and we've been able to start with a deployment discussion of this kind of chatbot on specifically their information that they give to their health workers as trainings, as pamphlets, as leaflets to give to people, instead creating chatbots that they can also use to just ask the people to text a number. And that's much easier to get to the younger audience who's already kind of tech savvy, more tech savvy than the older audience, can reach out to these chatbots, get this information. Their intervention was physical. So the research we read was we created a physical intervention. There was a massive uptake in menstrual health products that they gave to these young women. And we're hoping that this kind of digital intervention can scale their physical intervention technologically to a larger audience for the same cost. I'll summarize, or I'll close by sharing more about the team. So this is the team of students that I worked with. Not complete, there are more people here, but a bunch of these people are machine learning engineers, data scientists now, work in industry, but a large number of them are still students. So they're undergrads, they're seniors, they're coming out of college. And it's just a testament to the ability of students today to build this kind of system without like much supervision. Like I was the only person really they were working with at the time. There was one, all of these partner organizations that came in, they gave us some engineering support in terms of building stuff out faster. At the end of the day, we scaled it, built it out. Now we're scaling it to different platforms independently. So what I want to say is, like, when you go out there, when you have projects, try to look for students. I'm pretty sure you'll be surprised at how well they can help you execute those things. I'll close with a summary. We used interaction networks to track coordinated behavior online. We are scaling this and already scaled this to different cross-platform applications. We're trying to develop more Global South-focused tools, because when you develop tools for the Global South, you include the Global North. It's not always vice versa. And we're prioritizing multilingual content, multimodal data analysis, and trying to understand more about messaging apps, because those are really where a lot of the vulnerable population is more susceptible to online harms than the rest of us. So we're called SimPPL. The idea here was we wanted to simulate information spreading between people. One day we hope to do that. Today, this is the project I have to present to you today. Thank you very much.
Questions, raise your hands and ask it all the way the other side. I thought so.
So thank you for the presentation. So to the degree that you're comfortable, can you share some of the methodology and some of the challenges you had on creating those data points on the social media platforms? Because specifically, other than Twitter, a lot of these platforms don't expose APIs or things of that sort, right? But at the same time, you have terms of use limitations with regards to what you can scrape, even if it's publicly available. So if you wouldn't mind kind of diving into that a little bit more.
Absolutely. So I guess better than what I can tell you, there are people who have published research into this. I can flag one particular instance because that's an entire document of terms of, this is how you want to violate terms of service, and I don't have that memorized, but Kiran Garimella is one of the researchers who presented to us about WhatsApp data collection and how you can do that without violating terms of use. And they have, if you look up that name, WhatsApp doc is one of the papers they wrote. But related to that, they have a bunch of literature up about how you can collect platform data without violating terms of use of different platforms. In our case, Twitter was trivial because at that point, the API was open. Some people tell me Twitter data is still possible to collect. I don't think I'm at liberty to share that information about how they do that. Other platforms, specifically public information, is okay to collect. So I don't know if people knew this, but Facebook actually lists in one of its blog posts on some policy, on some page where it says comments to Facebook posts are public are okay to collect, just don't DDoS us, and you need Facebook permission in order to be able to do this, but it is public information. So there are like these middle grounds where it's not explicitly discussed, but it is implicitly understood that if you get the right people to give you permissions, you're able to collect some platform data. And the third thing is, for us, I guess it's, I don't want to say unfair advantage, but the advantage is we're doing research around this. We're not generating any revenues out of this. The intention at the end of the day is for platforms to make the changes. We're just the guy who point them in different directions, saying, here are the problems. and we do that for them for free. So in theory, like, we're doing them a service, and we should have more data access, but in practice, as you can see, the industry doesn't really support that perspective. So
that's why they said yes to you, maybe not to others.
it depends. Like, there's a lot of ways in which I see industry platform partnerships. So there are companies that work with platforms directly. And this was years ago, like, it's not even recent, but there are companies that have been working over the years with platforms. They get privileged access to platform data. I don't think I want to name the companies because this is all recorded, but there is a model out there where companies are able to get access to platform data without, like, some companies the platforms are invested in, without that being the case, you can still get access. Again, it's like a social problem where approaching the right people is key to getting the data for you. Thank you for the question. Any other questions? All right. If not, thank you for attending. I appreciate it.